Question 14. So for this one, what you need to know is that cos theta is 1 minus t squared on 1 plus t squared, where t is tan theta on 2. And to do the substitution, we need to work out d theta in terms of t. So let's differentiate this. Derivative of tan theta is sec squared, and then by the chain rule, you also need to multiply by the derivative of this. So we'll get a half out the front now. And then we actually need that in terms of t rather than in terms of theta. So sec squared is the same as 1 plus tan squared. And then that's t. So we've got half of 1 plus t squared. And let's move, oh yeah, we need to solve that for d theta. So dt is that times d theta, and then let's just shift all this over to the left. So you'll get 2 dt on 1 plus t squared is d theta. And then we also need to work out what t is when theta is 0 and pi on 2. So when theta is pi on 2, we get t is tan of, that'll make pi on 4. And that is 1. And then when theta is 0, we get t is tan of 0. Oops, that was meant to be a colon. Tan of 0, which is 0. Okay, so now we can say it's the integral from 0 to 1 of d theta, which is 2 dt on 1 plus t squared, all of that over the 2 minus cos theta, which is 1 minus t squared on 1 plus t squared. Now that looks really messy, but we can clean up this fraction by multiplying top and bottom by the 1 plus t squared. So on the top, we're going to get just 2 dt, and then on the bottom, 2 times 1 plus t squared minus the 1 minus t squared. Okay, so let's just simplify that denominator. So we'll have 2 minus 1 is 1, and then 2t squared minus a negative t squared, so 2t squared plus t squared, which is 3t squared. Now let's think about how we're going to integrate that. So this looks a lot like the one on the formula sheet, where it's like that, except that we've got this 3 here that we don't want. So let's divide top and bottom of this fraction by 3. So on the top you're going to get 2 over 3. Let's actually bring that out the front because we just want to have like a 1 there. So we'll have 2/3 integral 0 to 1 of, I'll just put the 1 there and leave the dt over there. And then we've got 1/3 plus t squared. So I've just divided top and bottom of that by 3, moved the 2/3 out the front and moved the dt there. So now it's in that form with a equals 1 on root 3, if a squared is 1 on 3. So we can just apply that. So we've got 2/3 times 1 on a, which is root 3, then arctan of, x is t, so we've got t divided by 1 on root 3, which is just root 3t, and plus a constant. So, oh, not plus a constant because we're doing a definite integral, so that's from 0 to 1. Okay, so we just need to plug in the 1. So we've got 2/3 root 3 times arctan of root 3 times 1. So arctan of root 3 is 60 degrees, which is pi on 3, since we're working in radians. And then when you plug in the 0, you just get 0. So you can put that in if you like. And then we just need to simplify that. So we've got 2 pi root 3 over 9. That's the answer to that one. Part B. So with this kind of question where we've got acceleration in terms of the velocity, what we need to do is use the fact that acceleration is the derivative of velocity with respect to time, and then by the chain rule, that's dv by dx times dx by dt, and then dx by dt is actually velocity. So now we can rearrange that and say a dx is v dv. Now you can just memorize that if you like, you don't have to derive it each time. But that's where that comes from. And then we can plug in the g minus kv squared. So because we want to get all of the v's over one side and like all this stuff with x over the other side, what I'll do is just divide both sides by that. So dx is v over g minus kv squared times dv. Now in the solutions, which they have released now, they do this as an indefinite integral, so you've got like something plus c, and then they use the initial conditions to solve for c. But what I like to do is do it as a definite integral, so I'll say integral from where x runs from 0 up to h, that is the integral. Now when x is 0, v is 0, because it said it was falling from rest. So that means at the start the speed is 0. So that goes from 0 up to whatever speed it is when x is h. So I'll just call that big V, because really we should have like a different variable here from the one that's in there. Okay, so on the left, that integral is just x. So you've got x from 0 to h, that's just h. And then on the right, we've got something that looks a bit like, you know, where you, if you've got ln f of x, when you differentiate that, that makes f prime of x on f of x. So we've almost got something like that, because the derivative of that is negative 2kv. So if we just sort of imagine that that is what we had, but I've added this bit here in, so to compensate for that, we need to divide by it. So this is now the same as that, but now it's in this nice form where it's like that. So we can integrate that quite easily. So 1 and 2k, k not h, got log of g minus kv squared, and that's running from 0 to v. So we can just plug those values in. Negative 1 on 2k, log of g minus k big V squared minus log of, that's meant to say ln, not weird squiggle. Plug the 0 in, we got ln of g. Okay, so I prefer this method because, like, I don't know, it's just neater. You don't have to mess around with getting the integral and then solving for c and then plugging that back in and so on. Like, all of that is just wrapped up in this definite integral. So I find it neater and just more fun that way. Okay, so now we can just simplify this. Personally, what I would do is use the log laws to turn this into ln of g minus kv squared over g. If you're like not comfortable with the log laws, what you could do is shift this over first and then like do e to the both sides. So you've got like e to the all of that, and then you can use the rules of exponents to manipulate that. So you'd have like e to the that divided by e to the that, and then yeah, it would simplify to the same thing, but I prefer using the log laws. Okay, so we've got h equals that. Then let's shift that over, so we've got negative 2kh is log of this, and let's actually divide through by g, so we've got 1 minus k on g v squared, and then we can do e to the both sides. Right, and then, so we just want to solve for v. So what I would do here is move all of that over to the left, all of this over to the right, so you'd get k1g v squared is 1 minus e to the negative 2kh. And then we can shift this over. And then you can square root both sides. So let me just get rid of that and write the square root there. Now normally you would have plus or minus, but because they asked for the speed, you know, v is going to be positive, so you could sort of justify that by saying v greater than 0. So that's it for that one. Part C. So we want to rewrite this in terms of in minus 1. So let's just keep an eye on where we're going. So we want to get to x to the n minus 1 root x plus 3. So that's in minus 1. Now we could do that by using integration by parts, because when we differentiate this, we're going to get the n minus 1 there. So that gives you a good clue on you know, what to do with this question. So we could say in, so apply integration by parts. I think of that as you integrate one of the functions and then you differentiate the other one. So because we want to differentiate this one to get the n minus 1, we got to integrate that one. So we leave that one alone. Think of that as x plus 3 to the half. So when we integrate, we got to add 1 to that power to make 3 on 2. And then we need to multiply by 2 on 3 to compensate for the 3 on 2 that comes out the front when you differentiate this. Okay, so we've got that. So we do the integrate that one, and then we differentiate this one. So that makes n x to the n minus 1, and then this again. All right, now let's see what this makes. When we plug in the 0, we get 0 there. And when we plug in the negative 3, we get 0 there. So that whole thing is just 0. We've got some constants here, 2/3 times n. I'm going to bring that out the front. Now, with this x plus 3 to the 3 on 2, like we don't really want to have that. We want to have something in terms of root x plus 3. So what we could do is turn that into x plus 3 times root x plus 3. Now that seems a bit closer to where we want to get to. Alright, and then what we can do is like expand this bit. So we'll have negative 2n on 3 integral. So that times that is x to the n, and then that times that is 3 x to the n minus 1. And then we can split this up into two different integrals, like with the x to the n times that, and with that times that. So negative 2n on 3 will have the integral from negative 3 to 0 of, so that times that, and the integral from negative 3 to 0 of that times that. All right, now that's very useful because this is just in, and this is just 3 in minus 1. So we've got that times the negative 2n on 3. On the left here was in. And then we just need to solve that for in. So what you want to do there is expand that and then bring all the i's over one side. So you've got in and then shift all of that over, so plus 2n on 3 in. And then that equals that times that. The 3's are going to cancel and you get negative 2n in minus 1. And then this is 1 plus 2n on 3 in equals that. And then we can just shift that over. negative 2n on 1 plus 2n over 3in minus 1. And then we don't want to have like a fraction within a fraction, so you just want to multiply top and bottom of this by 3 to get rid of that. So we'll get negative 6n on 3 plus 2n in minus 1. So that's it for part 1. And then we wanted to find I2. So using this formula, we could say that I2 is negative 6 times 2 over 3 plus 2 times 2 times I1. So that'll make negative 12 over 7 I1. Now, can we work out I1 yet from that? Still a bit weird, x times root x plus 3. Why don't we go down to I0? So we could say, use that formula again and say I1, actually let's just replace it there, 12 on 7, times I1, which is negative 6 times 1 over 3 plus 2 times 1 times I0. Now I0 we can work out because that's just integral of x to the 0 times root x plus 3, which is just integral of root x plus 3, which we actually worked out already when we were doing the integration by parts. So we can say that this is, those negatives cancel. You've got 12 times 6, which is 72 over 7 times 5, so 35, I0, which is integral from negative 3 to 0, root x plus 3, which is 35 times, that was 2/3 x plus 3 to the 3 on 2, from negative 3 to 0, which is, when you plug in 0, we just get 3 to the 3 on 2 here, which is 3 times root 3. And when we plug in negative 3, we get 0, so we can just ignore that. That 3 cancels with that. So we've got 2 times 72, which is 144, root 3 over 35. That's the answer to that one. Part D. So the probability that A wins just the first game is 1 on 3. And then if you want to work out the probability that they win the first and the second, it would be 1 on 3 times 1 on 3, and so on and so on. So 1 on 3 times 1 on 3 times 1 on 3 to the power n, because there are n games. Okay, now part 2. So the 2 on 3 to the n, that's the probability that C never wins, because the probability that either A or B win is 2 on 3. So you've got that for n games. But that would include the possibility that A wins every single game or B wins every single game. So we need to exclude those. Each of those are 1 on 3 to the n. So you could say something like, the probability that C never wins is 2 on 3 to the n. The probability that A always wins is 1 on 3 to the n. And the probability that B always wins is also 1 on 3 to the n. And we need to exclude these two, so it would be that one minus that one minus that one, which gives you what we're looking for. So that's part 2 done. Let me just clear this to make some space. For part 3, if you just had a complete mental blank about how you could work out the probability that each player wins at least one game, what you can do is kind of like work backwards from this and reverse engineer it and try to figure out how one might come to that. So in your rough working, you could sort of try expanding this, and that makes 1 minus 2 to the n on 3 to the n minus 1, plus 1 on 3 to the n minus 1. And then you could probably guess that this would be involved somehow. Now this is 2 to the n on 3 to the n minus 2 on 3 to the n. So if you multiplied this by 3, that would actually give you this bit. So you could think, okay, maybe it's 1 minus 3 times the bit from part 2. And then, so that gives you that, but it also gives you a plus 2 on 3 to the n minus 1 when you expand that. So to get instead a 1 on 3 to the n minus 1, we have to subtract 1 on 3 to the n minus 1. So you can kind of like see if you can figure it out from there. So from there you can kind of think, okay, that is actually 3 times the 1 on 3 to the n. So what it looks like is we've got everything except for 3 times that and 3 times that. So that's actually because the 3 things that can happen is that like either one player wins every single game. So because there's 3 different players, that can be that times 3, because you've got like A winning every game, or B or C winning every game. So that gives you that bit. Or you've got just 2 players winning every single game. So that would be 3 times this, because you've got 3 choices for which player doesn't win any. So you could say something like, the 3 possibilities are that either one player wins every single game, and the probability of that is 3 times 1 on 3 to the n, or 2 players win all the games, and that's 3 times 2 on 3 to the n minus, yeah, that bit from part 2. Or each player wins at least 1 game, and that's what we're trying to work out. So if these are the only 3 possibilities, then this one is going to be 1 minus the other 2. So we want 1 minus 3 times 1 on 3 to the n minus 3 times the 2 on 3 to the n minus 2 times 1 on 3 to the n. And then we just need to sort of do this bit that I did here in reverse. So this makes 1 minus, so that's 1 on 3 to the n, so you've got 3 on 3 to the n, which is 1 on 3 to the n minus 1, if you divide top and bottom by 3. And then that's 2 to the n on 3 to the n, and then multiplying that by 3. You get 3 to the n minus 1. And then we have 2 on 3 to the n minus 1. And then we can make a common denominator here. So 3 to the n minus 1. This one will be 3 to the n minus 1 on 3 to the n minus 1. And then you've got the minus 2 to the n. Oh, sorry, that should have been a plus, because those negatives cancel. And then you've got like the 2 minus the 1. Gives a 1. And that's it. Alright, stay tuned for question 15. Or if I haven't uploaded that yet, then you can also check out the 2017 exam videos that I did earlier.